Today we're going to talk about writing and solving inequality application problems. The very first problem, we're just going to write the inequality so we can get comfortable with it. And then the next three we're going to write and solve. And then number 5 is a special case. And I'm just going to show you how to do it once, so you're not going to have any problems like that on your homework. The first problem says, Albert earns $3.50 for each hour he works. If he wants to earn at least $52.50, how many hours must he work? So the important information that they gave us is that he earns $3.50 for each hour, and that he has to earn at least $52.50. Well, if they say $3.50 for each hour, we know the word each means that we're going to be multiplying. That's multiplication. And we don't know how many hours because it asks us how many hours must he work. So that's what we're going to identify as our variable. Our variable is x equals the number of hours that he works. Now there's a new term here, the term at least. At least says that he needs to earn $52.50 or more. So when they say at least, the value we're looking for can be equal to $52.50 or it can be greater than $52.50. So anytime you hear the words at least, you're going to use the greater than or equal to inequality symbol. In this case, they're telling us that it is $3.50 for each hour. So that says $3.50 times the number of hours. And they have to earn at least $52.50, so he can earn more than or equal to $52.50. Because at least means I have a minimum. The minimum amount that he needs to earn is $52.50. So in this case, this problem is 3.50x is greater than or equal to 52.50. Okay? Now, normally I would have you solve this for x. In this case, you would divide both sides by 350. And when you have x, then you would write me a statement answer because it's a word problem. But for this case, all I want you to do is get comfortable with writing the equation. So once you write it, you're done. Then on the next problem says, the daily production cost for a skate factory cannot be more than $5,400. It costs $15 in materials to make each pair of skates, and the daily operating costs are $900. How many pairs of skates can be produced under these circumstances? So the important information they gave us is cannot be more than $5,400. And when they say cannot be more than, they're saying that it can equal $5,400, but it cannot be more than that. So it would have to be less than or equal to. Because in this case, it says cannot be more than. They also tell us it costs $15 in materials to make each pair of skates. So $15 for each pair. We don't know how many pairs because they asked us how many pairs of skates. So we're going to say x is the number of pairs of skates. And when they say $15 for each pair, they're telling me I'm going to multiply 15 times the number of pairs. And they also, in this case, have a daily operating cost of $900. That's like a one-time fee. It happens one time. It's not going to be multiplied times anything. It's just going to be something that you add on to the end. So in this case, we have 15 times the number of pairs of skates, because that's 15 per pair, 15 for each pair, plus the $900 operating cost. And all of this can be no more than $5,400. So it can equal $5,400 or it can be less than $5,400. So we have to use less than or equal to. So you're going to solve this for x. The first step is going to be to move the 900 to the other side by subtraction. And you get 15x is less than or equal to $4,500. Because 5,400 minus 900 is 4,500. Then I need x by itself, so I'm going to divide both sides by 15. And I get x is less than or equal to 300. Now, this just tells me a value. It doesn't tell me what it means. So since they gave me the problem in words, I'm going to give it back in words. What does x is less than or equal to 300 mean? What it means is a skate factory can produce 300 or less pairs of skates for $5,400 or less, right? Because if you produce less than 300 pairs, it'll be less than $5,400. Oops, I misspelled the word skate. Need to add an E in there. So a skate factory can produce 300 or less pairs of skates for $5,400 or less. The next problem says, a group of 3 friends went to the movies. After paying for their tickets, they had a total of $10 to spend on refreshments. Excuse me, that's a mistake. Wait a minute, it's a mistake when typing this, so please change that to $11. Sodas cost $1.50 each, and a box of popcorn costs $1.75. How many sodas can they buy if they purchase 2 boxes of popcorn? Well, I noticed right away that they have a total of $11. If all they have left is $11, that means they cannot go over $11. So they can spend less than $11 or they can spend exactly $11. So we're going to use less than or equal to there. Then I see I have 2 variables. They tell me sodas cost $1.50 each. So that tells me that X is the number of sodas. And they tell me that a box of popcorn costs $1.75. So Y is going to be the number of boxes of popcorn, and we're just going to abbreviate that to number of popcorns. It's not grammatically correct, but it'll work for this problem. And they tell me that it's $1.50 times the number of sodas and $1.75 times the number of popcorn boxes. And this total needs to be less than or equal to the total amount they have left, which is $11. So 150x plus 175y is less than or equal to 11. Then I notice that they say, how many sodas can they buy if they purchase 2 boxes of popcorn? They actually give me how many boxes of popcorn they're going to purchase. So I'm going to replace this y, that stands for the number of boxes of popcorn, with the 2 boxes that they're going to purchase. So I have 150x plus 175 times 2, which is less than or equal to 11. Now I'm going to solve this for x. The first thing I'm going to do is my multiplication here. And I get 150x plus 175 plus 175, which is what you're doing when you multiply times 2, is going to be 350 is less than or equal to 11. Then to solve for x, the first thing I need to do is subtract 350 from each side, and I get 150x is less than or equal to 750. And then to get rid of this 150 here, I'm going to divide both sides by 150. And I get x is less than or equal to 5. Now I have to give it back in words so I know what the number means. Because in this case, when we say x is less than or equal to 5, what we're saying is that they can buy 5 sodas or less. Which, to be honest, if there's 3 people going to the movies, they're probably going to want to buy 3 sodas, right? So we're going to write a statement that says, they can buy 5 or less sodas if they buy 2 boxes of popcorn. I'm going to give you just a moment to write it down, and then I'm going to move on to the next problem. Don't forget, guys, that you can pause these videos at any time. If you're trying to write something down, pause the video, write it down. Okay, next problem, number 4. Kevin's history grade will be determined by the average of 4 tests. He received a 76, an 85, and a 74 on the first 3 tests. He needs to get an average of at least 80 to receive a B. What is the minimum he can make on the 4th test to receive a B in history? Minimum. When they say minimum, or they use the words at least, they're telling you that the grade he needs to make can be greater than or equal to that grade. Because minimum means that that's the lowest value, so you can always be bigger than that, okay? Now, they tell me that he's taking an average. we have to remember that to find an average of numbers, you have to add up all the numbers and then divide by the number of numbers you have. In this case, we know that we're going to be dividing by 4 because there are 4 total tests. We also need to identify our variable. We need to define it. In this case, our variable is going to be that 4th test. We don't know what it is. So I'm going to say x equals the 4th test. And I'm going to write an equation that uses the average. So the average of the test is the first test plus the second test plus the third test plus the 4th test, all divided by 4 because that's how you find an average. And this score has to be greater than or equal to 80 for him to get a B. That average has to be greater than or equal to 80. So the first thing I'm going to do on this problem is I notice that I have a fraction, and I do not want a fraction. So I'm going to multiply both sides of the inequality by 4, which is my common denominator, to clear my fraction. Now we're going to act as though this stuff on top is in parentheses, and anytime you're multiplying by a fraction that's outside the parentheses, everything in the parentheses stays the same. So we're going to copy that down, 76 plus 85 plus 73 plus x is greater than or equal to, and in this case, since I have 4 times the 4 on bottom, and that's like saying 1/4, and 4 times 1/4 is 1, this denominator cancels, and all I'm left with is what was on top. Then I have 4 times 80, which is 320, and now I'm solving for x. My first step is going to be to combine like terms. Oops, I went a little too far. When I combine like terms, I get 235 plus x is greater than or equal to 320. Now I'm solving for x, so I'm going to subtract 235 from each side because it's being added. And when I do that, I get x is greater than or equal to 85. So they have to make, on the 4th test, an 85 or higher to get a B in history. So we're going to write that statement out. The minimum score that Kevin, he can make on the 4th test is an 85. Make sure you're always boxing your answers. Okay, last problem. This one's a little bit different. This is actually what we call a compound inequality, and we're not going to do any of those this year, but I am going to show you how to set this one up because this one relates back to domain. In real life, we've talked about in our application problems that domain is like your limits. You can do only so much of this, and you can only go this high. Well, that's what this is. This is exactly your limits. What it says is on an interstate highway, the maximum speed is 70 miles per hour. And the minimum speed is 45 miles per hour. If x represents speed, then write an inequality to express this condition. In this case, what they're saying is that x is speed. This is a domain value. The domain in real life, my limits are I can go no less than 45 miles per hour. I can go no more than 70 miles per hour. So my speed is going to fall somewhere in between. And since x represents speed, that goes in the middle. Now I can be exactly I can be driving exactly 45 miles per hour, so I could equal 45, or I can be going faster than 45 miles per hour. So 45 is less than or equal to x because it's the least value. Then I can be going exactly 70 miles an hour, or I could be going less than 70 miles an hour because that's my greatest value. So my domain value would be the set of numbers that are between 45 and 70. And there's nothing to solve there because we were just showing you how to set up a domain value. If you have any questions, please make sure you are going to tutorials. We're not going to spend a whole lot of time on this stuff, so you need to be asking questions. And again, if there's anything in here you missed because I was moving too fast, please pause the video, go back and watch it again.